They should start now. But it is 2 sessions.
Yes, good morning. It is 2 sessions. Yeah, but we're still waiting. What time do we start, please?
So the presentation outline. First, we have the statement of problem, the objective of these projects, relevant information about the study area, materials and methods that were used in the projects, results and discussions, and then lastly, the conclusions and recommendations. So the problem statement, the Global Navigation Satellite System, that's the GNSS, which constitute the GPS, the Beidou, the compass, and others, is the basic for the basis for modern positioning applications. And some of these applications cannot be made without reference because it deserves highly geodetic observation. And we have several techniques for GNSS positioning operation. We have the static, the DGNSS technique. We also have the real-time kinematic technique too. And the DGNSS technique, the DGNSS technique is the most effective used among others. And due to that, it has resulted in the high demand of receivers and post-processing software. And some of these software also come with varying accuracy. So therefore, the works performed by surveyors are different when we check the results. So this study therefore has assessed or compared the accuracies of the various processing software. And the software that will be focused on are OSPOS, Magnet Tools, Trimble Business Center, and Spectrum Survey. Now, the objective of the project is to compare and evaluate the accuracy of the various software in UTM and in Ghana National Meter Grade. Now, the study area. There is a map of the study area, which is Taquansaye Municipality. And the municipality has a total land area of 1,045.65 kilometers square. It has also served as a hub for mining operations for various years. We move on to the materials and methods that were used. Now the materials. First, we have the GNSS data, which was acquired on the field. And we have Stonex GNSS receivers, which were also used to collect the data from the field. We have Microsoft Excel that was used to perform certain statistics. And Magnet Tools, OSPOS, Trimble Business Center, and Spectrum Survey software are the various software that were used to process the data that was acquired from the field. Now, the method used. First of all, a reconnaissance was conducted to know how the work will go about. And during the reconnaissance, a total number of 15 known pillars within the study area were selected for the project. And after reconnaissance, data collection also took place. And the data collection, the DGNSS positioning technique was employed, where a core station was used as the reference and 2 GNSS receivers were taken to the field to acquire information from the satellite. And after enough information has been acquired, these receivers were taken to the office. The data was downloaded, converted into RINES, and then post-processed with the various software, that is Magnet Tools, OSPOS, Trimble Business Center, and Spectrum Survey software. And after the processing, the accuracy assessment also came in. And the accuracy assessment, it comprises of the calculation of the horizontal positional error, the residuals, the standard deviation, and the root mean square errors too were considered. These are the various formulas that were used in the assessing the accuracy assessment. So the residuals, we have the difference between the actual value and the computed value. And the horizontal positional error too, we have the square roots of the change in northings and plus the square of the change in eastings. The standard deviations too. We also, okay, so method, next slide. Yeah, next slide. similar. Now the results and discussions. This is a table showing the deviations in UTM for the various processing software that were used. We have the results for magnet tools in Northerns and Easterns. We have the deviations for OSPOS 2 in Northerns, Easterns, Trimble Business Center. We also have the deviations for Northerns, Easterns, and the Spectrum Survey too, we have the deviations for Northerns and Easterns. Okay, this is also a table showing the root mean square errors in UTM for the various processing software that were used. So magnet tools, we had 1.9167 meters. The OSPOS 2 gave a root mean square error of 1.9457 meters. And Trimble Business Center gave a root mean square error of 3.3659 meters. Spectrum Survey also gave a root mean square error of 2.6231 meters. This is a graph of the horizontal positional error for UTM coordinates. So this is how the various stations, how the points are deviating from its original position. Next slide. Okay, there is also a table showing the standard deviation in War Office, that's the local coordinate system, for magnet tools, Trimble Business Center, and the Spectrum Survey. This project, OSPOS couldn't process in the national, the local coordinates. So during the results and discussions for the War Office, OSPOS wasn't considered because it didn't give any results here. This table also shows the various root mean square errors for the software that were used. That's magnet tools, Trimble Business Center, and then Spectrum Survey. The
However, there may be variations of plus or minus of about 1 minute, because you know our GPS start and stop time. Your watch or clock may tell you that it's time, but it's either 10 or few seconds before time, or so we could not measure as precise as to the closest seconds. So the same data set was post-processed in the various software in UTM, and then we send the same data sets to OSPOS, and they post-processed and they return the results to us, all in UTM, the universal system. So I've answered the first question. Well, I don't know if I've answered it, but that is what we did. So it was a very fair research. The same data set you post-process in this system, the same data set you post-process in that other system. Let's check the results. So it was very fair. We did not do repeated observations. Then you come back and measure again for the other system. No, the same data sets run in both systems concurrently. Then Mr. Chairman, Surveyor Chairman's question that we knew that in our comparison in the Ghana National, we wouldn't get that of OSPOS, but we still did it. This was done purposely to expose to our fellow surveyors and to we, the researchers, that we have a bit of gap in our geodesy aspect, that is our satellite geodesy aspect in this country, that we need to come together and augment it. Because as we sit now, OSPOS is a system that post-processes data in UTM, right? And OSPOS does not care about our local system. It's a Western system. And yes, thank you. So they don't really bother about our Ghana National. They don't have it in their system. So this means that stakeholders must consult them and either work out and ensure that they incorporate our national coordinate parameters into their system, so that anybody who wants to post-process his data in the Ghana National system can as well send to OSPOS to do that. However, we can also create our own online or web-based, localized-based OSPOS or Ghanaian system, where we can also run our system. Thank you. Yes, I think, yes, in fact, that was why we were limited. We wanted to extend the post-processing to, how do we call it, this other software, which Leica, Leica Infinity. We have Leica Infinity for post-processing. We also have one for Stonex. They also have their own post-processing software. In fact, we wanted to run about 10 different post-processing software to at least cover a broad spectrum, but we were limited in resources. Resources in the sense that we did not have the official license to run. So we had to consult people who had the license to assist us in running or processing our data. So it is not open source. All these software are not. You have to pay. A few leaflets. The opportunity, I've not really probably worked so long there, so I don't know which ones are most stable. We do that because we want to draw closer to the most probable value, right? So fortunately, Takwa is an area I have worked for over 13 years as well. My other artists have worked in Takwa for about 20 years. Confidently, I can talk about Prof. Yakubu. So we took note of the stable controls and we use that for the post-processing of the data. That is one. Then my second answer to your question is that if you look at the post-processing software, the base coordinates, right, have not been varied. If you are running in, how do I call it? The base coordinates for each of the post-processing software is not varied. It is the same. So even if there is an error in it, it is inherent. It translates right. Yes. So, but the research took an assumption that holding all other factors constant, and the error is as a result of the post-processing software. Let's look at it. That's what we did.
We have allocated, yes, please. The strategy is that because of time, there are other presentations we need to take on board. We will not take it away, but please write the question down.
Our presenter is by the name Azar Amatepe. Is Azar Amatepe around? Azar Amatepe. Okay, so we'll move on to the next presenter. The next presenter is presenting on automating the preparation of cadastral plans. And our presenter is by the name Richmond. K. Mensah-Sam.
Okay, thank you very much. Good morning, everyone. I would like to use this opportunity to thank SMD and a software developer by name Efrifanum.com. Sorry, Efrifanum Limited. We've all been preparing cadastral plans, and most of the time we try to use AutoCAD to be able to prepare these cadastral plans. Now I'm looking at smart thinking, how we'll be able to automate the preparation of cadastral plan. And so here, I've been able to come out with something. Thank you. Unfortunately, my presentation is more like a demo for you to be able to see how I'll be able to prepare the cadastral plan, but I'll simply go. We have methodology, results, and conclusion. So first of all, I just want to ask a question from the audience. Just a minute. Please, sir.
Okay. Basically, 20-30 minutes.
Thank you very much. So here, the preparation of cadastral plan is very complex and time consuming. And sometimes there are some errors that we incur during the preparation. And so here, we've been able to automate the preparation of the cadastral plan using some technology. Okay. And so the next slide. Next slide. With the methodology, we were looking at web technology with regards to mobile compatibility, and then Python programming software and geographic information system. So next slide. So this is what is going to happen. It's on a server for which you need to have the URL, which is the Uniform Resource Locator. And so once you type the URL, you'll be able to get this interface. Unfortunately, or it's not showing. And then you need to register. So once you register, there's a form that you need to go through. So you have your username, your password, the licensed surveyor, and then the licensed surveyor's number, and then sorry. So yeah, then the email address, and then if should in case you have a picture you want to show, that's fine. So next slide. So once you are able to do that, you can then use the username and password to register. The next slide. Then after the registration, what is going to happen is that now you need to input. So, please just a minute. Yeah, it's not too clear, but then you need to now have the owner name, whoever you are preparing the plan for, and then the region. The region is that the drop-down arrow. The district is also a drop-down arrow. The locality, you need to specify the locality. And then the reference station, you enter the reference station, and then the reference station coordinate. You enter the northerns and easterns, and then you enter the regional number. And then after the regional number, now here we have two options. The first option is to add the data manually by entering the XY coordinates. And then the second option is to import a CSV file format. Now, with the format, what you need to do is and a small letter Y. The beacon underscore name is also small letters. So once you do that, you have your XY, and then you just import. After the importation, then you get, next slide. Yeah, so after the importation, then you get this web portal, which the coordinate to be plotted, irrespective of the polygon, the shape, going to be plotted here, and then you can have then the attribute. And so here, an example is there, the information we previously entered. So once you have that, you have the bearing and distance, and then the beacon index. Once you have this, then the next thing is to what we call export. So with export, you have two options. One is to print directly from the system. The other is to export it to a DXF file. So once you export it to DXF file, then you get, next slide. Then you get this resource in a DXF format. Now here, all you need to do is probably do some few editing, because you realize that you'll be having the point IDs probably scattered a little. So you just need to do some few arrangements, and then you are done. So next slide. So this is just a picture of a PDF format of whatever you need to print out. Next slide. So in conclusion, all that we want to say is that the intended purpose for which we wanted to do this particular project or embark on this particular project has been achieved. Nevertheless, I'm here to seek for the opinions of my bosses here and my colleagues here to probably maybe be able to put things together if there are some errors or omission or whatever, for you to be able to correct this particular system. Once we are done, then probably I will encourage land surveyors to be able to patronize this system. Thank you very much.
Please, can we have questions for our presenter?
I want to congratulate the young old man for that presentation. My question simply is, you probably have to do a few further consultations by ensuring that all the challenges that we face in terms of the non-homogeneity of references are captured, so that there can be prompt or I don't know what the computer scientists will call it. If yes, no, or if there's that kind of prompt to ensure that at least you prompted them of all the gray areas where you are likely to have challenges. Did you verify this? Did you verify this? If yes, then you follow up. This is just as part of the improvement contribution. Thank you.
Thank you, Mr. Presenter. I was so shocked you are finished. You said demonstration.
Yes.
I don't know whether your
So
system didn't allow you.
yeah, it's not a system. Like I said, it's on a server. So I was asking them if they could give me the permission for me to demonstrate, because I have to use my laptop. With my laptop, yes.
Thank you very much for the presentation. It was not too clear, but I want to find out. The portion you said you put whether you're a licensed surveyor. I'm sure it's a marked thought. And if it's a marked thought, is it only for licensed surveyors? Because I know there are other people who are not licensed surveyors who are also geomatic engineers who also do plans. So is it really limited to them, or is just the demonstration are given, or is purely you have to put your licensed surveyor and number? That means it's restricted only for licensed surveyors to use, or if you send someone to the site, it's a geomatic engineer, but not licensed, also uses. That's what I want to find out. And what's the, has it got the size limit? Because what you show is a plot of, let's say, 0.42 is going to effectively the plot is huge. Let's I don't know whether you did say it about that one too.
Okay, thank you very much. We didn't actually hear the time frame. You know, you asked the gentleman the number of minutes he will use to prepare a site plan. Unfortunately, you didn't mention to us the time frame you would have used to start and to finish using your program. Can you break it down for us to see how fast that will be compared to the automated time we normally use? Thank you.
Depending on how fast one is able to use the computer, I don't think it should spend more than 5 minutes. Because all that you need to do, first of all, after processing your data, you need to have the file I just mentioned, the CSV file. Okay, so once we have the CSV file, it shouldn't take you more than 5 minutes. And the question where our senior Kwame Tinedu mentioned. So this is what happens. You only need to be careful, even though those prompts are not there, but you only need to be careful because you only need to have the, how do you call it? The original number, okay? The original number, and then the base station coordinates correctly, and then the base station ID. Once you have that, that is all. And with respect to what my senior colleague, Mr. Champon just mentioned, it is irrespective of whoever is preparing the plan. But all you need to know is that if the person is a regional surveyor or an official surveyor or a licensed surveyor. These are the three categories. Why? Because that information you are going to put there, it then gives you the opportunity to sign where we have so and so certified that. So it means that whoever is to sign the plan, that is the name you have to put there and the person's number. And we all know that cadastral plans are being prepared by two people, licensed surveyor and then an official surveyor. And so once you have that, you'll be able to now enter their respective names and number, and then you can sign.
Come in. Yes.
Okay, then that's fine.
Please, another round of applause for him, please. Our next presentation will be taken by Isaka. On the topic, assessing the performance of machine learning algorithms for urban land cover classification using multispectral satellite imagery. Is Isaka around to present for us, please? I don't. Okay. So, Mame. Mame Bua Mapuku. Okay. So, Mame Bua Mapuku is the lead author of this abstract. So she's the one doing the presentation for us. Okay. Yeah, she's around. Please give a round of applause.
Thank you. All right. Good morning. My name is Mame Bua Mapuku. And we are looking at assessing the performance of machine learning algorithms for urban land cover using multispectral satellite imagery. Now, our presentation would take this form. We are going to look at the introduction and then we'll run through to see some contributions and then future research direction. Please, we can go. Move to the next slide, please. All right, okay. So now we are looking at land use land cover and why land use land cover mapping is important. Well, land use land cover is a critical process when it comes to land management, environmental management, resource allocation in any region. Why? Because in order for you to do resource allocation, in order for you to understand the trend of changes, you first of all need to know how the land use has changed over time. as we heard from our seminar, I think 3 days ago, our speaker mentioned the importance of using satellite imagery to assess the impact of human activities on, our land cover. And to land use land cover, it comes back to land use land cover. Once we know the spatial distribution of our land use land cover, we are able to also make predictions to see how the land cover is likely to change in the future. So it takes us to land use land cover, like I said. Now, before you can conduct land use land cover change, you need to acquire a satellite image. And then when you acquire the satellite image, you cannot make meaning from the satellite image. So there is a process known as the image classification that you have to do. Now, the image classification is looking at the pixels in the satellite image. And then based on their properties, it may be spectral, it may be textural, it can group them. So the grouping of the pixels according to their features is what we refer to as image classification. Now, what has been the trend of image classification? We know that classical methods have been used. For example, the parallelepiped, the maximum likelihood classification, especially. That is one of the most commonly used classifier when it comes to image classification. But then these classical methods also have their challenges, because once you train, you give it training samples and you're able to classify the image. When you want to perform another classification, you need to pick training samples again. So it involves a lot of manual tasking, and then it's a bit cumbersome. This poses a challenge. Now, we need our land use land cover maps to be reliable, because we need to make informed decisions with this land use land cover maps. So the selection of the classification algorithm is also very important. Now, we are looking at the way forward. Luckily, the advancements in geospatial technology has come up with machine learning algorithms. And these algorithms helps us to perform land use land cover classifications. Now, these machine learning algorithms, they are the strengths when it comes to the weaknesses of the classifiers, the classical classifiers, like I mentioned. So for example, it is able to adapt to new data sets and give a very good generalization performance. As a result, this paper, we decided that, okay, we are going to assess some machine learning algorithms for image classification, and then see if indeed machine learning can also help when it comes to remote sensing image classification. After that, we are going to compare the machine learning algorithms to our classical maximum likelihood classifier. Now, our study area was the Greater Accra region of Ghana. Why did we choose the Greater Accra region? Because we know that the land cover type or the land cover feature of the Greater Accra region is of a heterogeneous mix. So we have settlements, we have water body, we have bare lands, we have some forest, we have some vegetation. So we chose the Accra as our study area. Now, the materials and methods that we used. We acquired satellite image from USGS website. It's an online-based website. And then we picked some training points. We picked about 2,440 training points from Google Earth, please. And then after that, we also adopted some accuracy metrics because we wanted to check whether indeed the machine learning algorithms were accurate enough to be used. So we used the recall, we used the precision, we used the F1 score, we used the kappa score, and then we also assessed using the overall accuracy. Please, let's move on. All right, now, this was the method that we used. For the first part, when we acquired our data set, we pre-processed them, then we generated the training samples like I mentioned earlier. After we did that, we sampled our training points to get the raster values. Because if you have the image, it's a stack of bands. So we had to extract each value for each band. So that was also done. Then we moved to the model formulation aspect of it. Now we considered 3 machine learning models. We considered the support vector machine, the random forest, and the k-nearest neighbor, in addition to the maximum likelihood classifier. We split our generated samples into 2. So we used 80% for training, and then we used 20% for testing. After that, we also converted the image. The image was in a TIFF format. So we converted it in an array format to get the pixel values as digital numbers. Then we trained our models, the 3 models I have mentioned earlier. We trained them, and after we trained, now the training is where we are teaching the model. So like I said, it's a machine learning model. So it learns based on the data you give it. So we trained it with the 80% of the samples that we had. And then after we trained, we wanted to be sure if it had been able to learn. And so we also tested the model. Then we did the classification. So we classified it. We had the accuracy assessment using the metrics that I mentioned earlier. And then finally, we converted our values. Like I said, we initially converted it to the array format. That's the digital format. Now, sorry, the digital numbers. After we were done, we converted it back to the GeoTIFF format. The results and discussion, this is what we had. For the purpose of this presentation, I am showing the image we had for the support vector machine and then the maximum likelihood classifier, which is the traditional classifier. So the one on the left is the image we had for the support vector machine, and the one on the right is the image we had for the maximum likelihood classifier. We just continue to look at the results, the discussion of the results from the accuracy metrics. The right is the maximum likelihood classifier. Exactly, yes, please. All right. So now when we checked, we realized that overall, for the entire work that was done, the support vector machine had a precision of 0.84. And then it had a recall of 0.82, an F1 score of 0.83, a kappa of 0.85, and an overall of 0.89. Now the recall is telling us how it was able to learn. Then the precision is telling us how it was able to predict. So when we look at the maximum likelihood classifier, which is highlighted in yellow, we see that it learned at a rate of 0.73, and then it's predicted as a rate of 0.76. The interesting part is what is on the next slide. That is, we also checked how each classifier performed for each of the land cover class. So this is showing its precision. So the precision of maximum likelihood when it was predicting for bare land, for forest, for vegetation, for urban, and then for water. Please let's move to the next slide, the figure 7. Okay. Now, if you compare the maximum likelihood, which is shown in red, we can see that when it was predicting, it was learning, sorry, the recall for bare land was the highest. It gave the highest when it was learning. That is for the first land cover class, which is bare land, and then the red, which represents the maximum likelihood classifier. Please let's go back to the previous slide. But then when it was doing the prediction, it predicted, it had the least value, the least accuracy metric when it was predicting for bare land. Please let's move on. Now overall, let's go to figure 9. This is just a visual interpretation of the overall classification results that we obtained, and it tells us that indeed the support vector machine showed robustness when it came to predictions. All right, now our conclusion, we are concluding on this that we have assessed the performance of the maximum likelihood classifier as against some machine learning methods, and we can say that the machine learning methods, especially the support vector machine, gives a better performance than the most commonly used maximum likelihood classifier. A model has also been adopted, which can be used for various land classification applications. Now, this is not the end of this work. It is in continuity. So our future research direction is looking at how we can improve again on the performance of the support vector machine, because the little challenge with the support vector machine is that it makes use of some parameters in order to carry out its classification. In selecting the parameters, we need to see how we can optimize them. And so we are going to adopt some meta-heuristic algorithms that will optimize on the performance of the support vector machine. Next slide, please. Now, these are the authors. Next slide.
You said when you had the data, you pre-processed. What did you do? Did you come to Accra or you did it with your computer in UMAT?
Okay, so the pre-processing were in three forms. We did correction on the image itself because as light picks the data, there are some environment atmospheric exactly. So we had to correct for the radiometric, the reflectances and all that. That's one aspect of it. Now there was also a bit of ground truthing that was done because you have to be sure that what we are seeing on the image is what was on ground. So a few places in the Greater Accra area were visited to ensure that indeed they were what we were seeing on the satellite image. That was for the pre-processing aspect. Yes, please. Thank you.
Thank you.
Okay, thank you very much. A maximum likelihood. You mentioned other methods of classification. Why did you decide to take the maximum likelihood and then compare it to the machine learning? Why not the parallel pipes?
Okay, so we first looked at literature. Even though the parallelepiped and the minimum distances have been used, it is the maximum likelihood that is most commonly used. So most of remote sensing image classification works are based on maximum likelihood. And because it was the preferred choice, we wanted to compare it with the other machine learning methods.
Okay, thank you very much. But research actually also shows, it's for purpose of learning, actually shows that the maximum likelihood among the traditional methods seem to provide higher accuracies. Thank you.
All right, thank you.
Please, what date of image did you use? You didn't mention it. What was it, Landsat or what? You didn't make mention of that.
It was a Landsat image. It was a Landsat.
And the dates, which dates did you use?
The dates for which you obtained the image.
For your images.
Okay, so the year was 2021. We used 2021 Landsat 8 imagery. Yes, please. Okay, thank you very much.
Okay, please, when you are asking the questions, kindly stand up so that we can capture you in the camera. We have our next presentation by Dugbate. I hope Dugbate is around. So Dugbate is doing a presentation on urban growth determination and prediction in the Upper Shama area, a case study. Is Dugbate around to do this, the honors? Okay, so T-Base is coming to initiate it for Dugbate. Let's give him a hand of applause.
Good morning once again, Mr. Chairman and senior surveyors here. I am Felix Tabase and I'm here to present on prediction of urban expansion in the Upper Shama area using artificial neural networks. My presentation outline is as follows: runs through statement of problem to conclusions and recommendation. Urban expansion is a major concern to many disciplines in the world, especially those of climate change activists. Urban expansion results in physical extension of the geographical footprints of various landed features of towns, sometimes as a result of an increase in population, thus leading to land use, land cover changes in such areas. As the population and infrastructure increases, this poses threats to the environment and also makes handling geospatial data very cumbersome. Therefore, the aim of this study is to monitor the expansion of, to monitor urban expansion, and then to predict urban expansion for the Upper Shama area for the year 2030, which we all hope to be there by the grace of God. Move. Yeah, so this research seeks to assess urban expansion in the Upper Shama area using an integrated remote sensing approach and a GIS approach, and also to predict the future of urban expansion within the Upper Shama area using artificial neural networks. Sorry, I hope I can use my pointer to control the pace myself. That will help my flow. Thank you. Sorry for taking your time. I want to be able to control the pace and the movement of the slides. Okay. Okay, you fix it. It's not time. Okay, good. Okay, so Upper Shama area or Upper Shama East District is located between latitude 4 degrees, 58 minutes and 0 seconds north, and 5 degrees, 4 minutes, 0 seconds west. Sorry, is an error. And north. Sorry, north. And then longitudes of 1 degrees 37 minutes 0 west and 1 degrees 52 and 30 seconds west. Move. Yes, these are the materials we used for our research. We had to get shapefiles for various features such as roads, the boundary of our study area, water bodies, and others. We also had to download a DEM, a digital elevation, for our research. We also use satellite data from the year 2000, that is May 2000. And then we also had satellite data for the year 2010. And then we had satellite data for the year 2020, all from Landsat 5, 7, and then 8, with the same resolutions, 30 meters. Move. Can you move it for me? Yes, still materials and methods. In our methods, we had to clip our Landsat data or our satellite images to a particular boundary in order to constrain our research to the Upper Shama area. We carried out atmospheric corrections to our satellite data, and we also carried out line corrections in the Landsat 7 data. And then we had a composite band creation within the methods. Then we use supervised classification because we went to the ground, we collected data, and we had to class that this is water, this is vegetation, this is development, this is an urban area. So we used the supervised classification method. And then we did area computation of the various land use, land cover types in our software. And then we finally did the prediction using artificial neural networks of the Upper Shama area. Yes, the artificial neural networks is just a basic algorithm, which is one of the early machine learning algorithms which is being used. And with artificial neural networks, it is made up of 3 components. We have the input layer, we have the hidden layer, and then we have the output layer. Now, the input layer in our case, we should take note that artificial or predefined data to be able to predict the future or to predict what is expected or what is not known. And so in this case, our input data is our land use land cover maps for the years 2000, the years 2010, and the year 2020. Now, based on that, that serves as our input layer. And then it goes in, and then iterations are being carried out within the algorithm, and then the output then comes out, which is usually the predicted layer. So if you consider this particular network, which operates like the neurons of a human being, it's been from how the neurons of the human being operate, which we all know we have the motor neurons and many other neurons that send signals to our fingertips and whatever to feel pain and all of that. It's been adapted, and you would realize that most of our methods and principles in science and technology are mostly mimicked from real life or natural entities. So, and then our output, which is going to be the predicted map for the year 2030 in the Upper Shama area. Next slide. So you will realize that in our land use land cover map in the year 2000, which is 0, we consider that as do our iterations from where we will learn. The machine learning algorithm will learn from the past and tell us what the future will be. You would realize that within the year 2000, Upper Shama area was basically dominantly a green area. And then in the year 2010, the red patches represent urbanized areas. You would see that the red patches are increasing. You would see water bodies are still constant. You can see the water bodies are constant, not unaltered. Then in the year 2020, you would see that urbanization increased so much within the Upper Shama area, while we still maintain our water bodies as constant. You would see that from the map. Can we move? So in that regard, we decided to take note of the various changes that occurred, more like land use land cover changes that occurred within Upper Shama area from the year 2000 to the year 2020. And we realized that urbanized areas within the year 2000 was 24.3009 square kilometers, while vegetation was so huge, considering 223.499 square kilometers. And within this, we realized that urbanized areas, the urban areas constituted approximately 9.8% of the entire study area. Then in the year 2010, we realized that urbanization had jumped after a decade from approximately 24 square kilometers to 68 square kilometers within the Upper Shama area, resulting to a percentage increase, which is approximately 27.7%. Then in the year 2020, we still did our land use land cover change detection, and we realized that there was another increase, once again, of about 154 square kilometers in terms of land size, and which constituted about 62.69%. Move. Move. I need to flow. Yeah, so this is just a graph representing the figures that we discussed. So you would realize that in the early days, in the year 2000, the highest peak or the highest, let me say, bar was vegetation, as you can see. And in the year 2010, it decreased. And in the year 2020, it came very low, while urbanization increased, or let me say urban expansion. Let me use the right terminology. Urban expansion increased, though urban expansion has a direct relation with urbanization. We can discuss that later as we move on. So we realized that there is an increase in urban expansion from the year 2000 to 2010, and then the year 2020, thereby indicating a positive graph for increase in urbanization, and then a negative graph for which indicates decrease in the vegetation. Next slide. Yeah, so we decided to do, how do we call it? Compute the changes that occurred within the various years. And that is in square meters. We decided to do that in square meters. And then you can see that in the year 2010, this figure stands very huge. I don't want to waste our time mentioning it. Stands survey is between is 0, the values of 0, the values obtained from 1 minus that of 0, and subsequently the values obtained from 2 minus that of 1. So you will realize that our reference is the 0. So between 2000 and 2010, this is the change in terms of percentage, as you can see in urbanization. And then in the year still, so you realize that the vegetation is increasing. It goes down to 37% and then also goes to 62%. So our artificial neural networks, after running the model, this now takes us to the prediction. So after running the model, we had to do kappa validation, and then we had the overall error. These are percentages. If you see these, they are percentages. So this was our predicted value, and then it falls within the acceptance limit by principle and by theory. If your predicted value from the model falls between 0.4 and then 1, considering a huge area in terms of a huge area like that, if you have an error between 0.4 and 0.1, it is supposed to be acceptable. And so we accepted our prediction from our algorithm because we were considering 0.5, which falls within the range. Next slide. So these basically are talking about this is our prediction model in terms of a pictorial form. That is in terms of, yes, a graphical form. That table we had represents that table in a graphical form, which tells us that these are the iterations. Whatever you see here are iterations, what we cannot see. So the algorithm is able to, those who do this, how do we call it? We have there's an online sort of stock exchange stuff. You say there's a graph, then you predict, and then you get some money falling in. I'm not able to remember that. This is how those graphs will always look like. You predict, then an amount is paid into your account. So these are the iterations, the prediction iterations. For the red stands for urbanized areas, and then the green stands for the vegetative areas. Can you move? Can you move? Yes, so still under results and discussions, we decided to look at the classification accuracy because, look, if you misclassify, you have a lot of errors in your work. You will be misrepresenting what you are talking about. You would probably see, how do we put it, a vegetative area, maybe assuming you are classifying forests, shrubs, and then grassland. If you misclassify, you may classify shrubs as forest and vice versa. I'm just using that as an example. So we need to look at our classification accuracy. And so in the year 2000, our areas still repeat as we discussed. And then you realize that our overall classification accuracy here is 86, which is good. It is an A. Our overall classification accuracy in 2010 is 82. There are a lot of factors that sometimes cause a bit of miscalculation, but we were able to take care of all of that by doing a supervised classification, by going to the ground to know what is there. I'm wrapping up. So you would realize that how do we call it? In the year 2020, this is what we have. Urbanized areas are red, green, and the predicted map or model, which today we are able to predict. If you have enough data, you can predict what will happen in terms of urban expansion in Ghana for the year 2050. If you have enough correct data, you can do that. So this is our predicted map that in the year 2030, this is what we are expecting to happen in Upper Shama area, holding all other factors constant. That is what comes in. If we take holding all other factors constant, this map does not hold. But holding all other factors constant, that the changes that occurred in 2000, 2010, and 2020 will continue, and those factors affecting those changes will continue. That tells us that we will have this happen in Upper Shama area in the year 2030. Can I have the next slide? Now, this is a trend map of what took place there. And then let's move so that questions can come because of time. So you would realize that in our prediction, this is our predicted map. This is the results of taking into consideration the land use, land cover change detection, plus that of the predicted in the year 2030. So you would realize that in the year 2000, you have a very low urban area in Upper Shama and the highest of vegetation, and it translates. But it shows once again that this is more like it's a linear graph. This is very linear, and it takes a constant path. So you realize that in the year 2030, we are expecting to have even more urban expansion, rather, and therefore a lot of vegetation will be depleted. So in conclusion, it can be concluded that in the year 2000, 9.8% of the steady area was urbanized or experienced urban expansion. In the year 2010, 27.7% of the steady area experienced urban expansion. Sometimes we interchange urban expansion. And then in the year 2020, we realized that 62.7% of area experienced urban expansion. And finally, our predicted model by using artificial neural networks, which is a machine learning algorithm, tells us that in the year 2030, we are expecting Upper Shama area to be urbanized by 91%. And it is recommended that other parameters, such as population, be incorporated into the algorithm in order to predict the effects of urbanization on urban expansion. Finally, it is also recommended that other models, such as the cellular odometer, should also be used to predict urban expansion to see which model best suits or gives best results. Thank you. My colleagues, Dubate Clement, I'm Felix, and then PB Larry is one of my colleagues or artists in this work. Thank you.
We can do better. We can do better. At this juncture, I hope some of you wrote questions to be asked for the other presenters. This is the point where you can actually raise your hand, and then you mentioned the presentation for which the question is being asked. Then we call on you to give it the question. So any hand for us?
No.
Felix, that's a wonderful presentation.
Sorry, I think it will be very appropriate that I recognize the presence of the Director of Survey and Mapping Division of the Lands Commission, His Royal Highness Tibulana. You don't always think I will get it wrong. So you're welcome, Director, and the audience of made up of distinguished participants, colleagues, professionals. We are deliberating on technical issues, including some of your own staff who have made presentations here. And we are happy that you found time to join us. Thank you very much for coming. And so Director Tibulana. Yeah, so we'll continue with the questions, and then when we take the general forum, which my colleague would be announcing, then we can continue from there. Thank you.
Felix, thank you for your presentation. With this presentation, I'm sure you're going to really scare us in the next 2050. The whole of your study area is really going to be red. But then you said that keeping everything constant, that I have a problem with. So I think that your study should go further if we say that we're going on a vertical development, or we want to suggest to development authorities that why don't we go on a vertical expansion? What happens to our land cover? Because we can't get the whole area to go red. So that will be an add-on that will at least send some signals out that indeed your paper is telling the authorities that no, we have to go this way, and that to add more taste to your paper. Thank you.
Mr. Chairman, I want to add to what Sowiewa said. Additionally, probably energy. You are not having electricity, and maybe electricity was sent to the area, and also other economic and social factors. Though we are doing remote sensing, these days the politicians take our work very seriously. So if we can add other economic and social factors which happen in the area, as far as what he said, the vertical expansion. Thank you.
Can I comment? Yes, thank you very much for your additions and your contribution to make a wonderful paper. We will take that into consideration. And it's very possible to take that into consideration. That is why I limited the work to holding all other factors constant. The reason being that there are so many factors, and artificial intelligence and machine learning has the opportunity or the ability to imbibe in it, all these factors, both social. That's the good thing about AI that is coming in. It has the potential of imbibing in itself social, economical, and geospatial factors. So I will take that into consideration, and I think this work is going to be, because one of the social factors is population. That's why in my recommendation, I indicated that further research should take into consideration the population and population growth, which is being measured based on urban growth, not urban expansion. There's difference in that. There's no time, but we can discuss that out of stage. There's difference between urbanization, urban growth, urban expansion. These are three different things, but they are interdependent. And that is also another future work we are looking at, how we can marry them, because so far we don't have a model, but there are theories that says that urbanization has a relationship with urban growth and has a relationship with urban expansion. Urban growth talks about population growth as a result of what? Rural urban migration and all those other factors, and high rates of birth, like we are doing in Africa. And then which is very positive. So we will take into consideration all the social, economical, and geospatial factors to make a wonderful paper.
Chairman, I have a last question for you. Okay. Lessons over, sir. I'm happy you've done a very good job. But the 10-year interval, I know you're just looking at the land cover, but then remember, government is putting in projects to help change again, like the planting for trees for the afforestation. So let's also look, if maybe you could look at doing another one, but capture those periods of those projects implementation, not that long, maybe within just a year interval, then we can see what that is also bringing up. Thank you.
Yeah, thank you. Yeah, Mr. Chairman, can I just add something? Just a minute and I'll go. Yes, thank you for your wonderful question. You see, we were limited. You see, African research, we have the researchers. You see, sometimes we say Africans don't like researching. We have one of the finest researchers in this world. You go outside, you see the work that Africans are doing, it will amaze you. Unfortunate for us here, authorities or various stakeholders, which the major stakeholder is government, is not interested in investing into research. And so we had to struggle to get the data for the various intervals. We would have gotten a better prediction. You see the classification accuracy. So where I saw, you saw 82. You saw 82 elsewhere, 81 and 85. If we had data for intervals of 1 year, we could have improved our classification accuracy as well as our prediction accuracy would have been very, very better. Therefore, coming out with a better model. But we look forward to a point when we can even have daily maps. And that is even AI can consume all of that. AI can consume even 1 billion of such maps and it will give you results. So that's the challenge. But if GHIS can support the UMAT team, we will do better research and then it will help the various stakeholders because this is about land and we are all about land. And God is the master surveyor, I always say, the creator of land. Thank you.
Thank you. Thank you. Thank you. Yes. Please, Linda Abusi, please, thank you for your presentation. It's a nice one. But I was also looking at the acquisition of images. You gave us month. So assuming you give us May, and then you give us, say, September, you see, you have difference in season. So you have rainy season, you have dry season. Is it not going to affect your results? Because in this case, it is what you put in that you are going to get. So I think next time you have to also look at the acquisition of the data too. Thank you.
Yeah, thanks for inputs. It all goes to limitation. So if you can assist us to get the data, the algorithm is there. We don't have the data, right? Yeah, so. Yeah.
Okay, please. Our time is fast spent, and we've made progress with a lot of information gathering, and I think at this point we would want to link what we've learned so far for the seminar and have an open forum. Now, this open forum, okay. Okay, so 3 more questions.
Good morning. Please, unfortunately, the person to answer my questions had unfortunately walked out. Okay. I had about 3 questions for him. The first one has to do with the presentation he just made. Now, I wanted to find out if he could have incorporated the layout of the districts, because as we know, the land use, we all talk about land use changes and things, and we don't factor in the planning scheme, because it could be possible that the changes that we are seeing or the anticipated, the prediction is based on what is in the layout of that community. My second question has to do with his first presentation, which was about the changes in the GNSS results from the post-processing. Now, I wanted to find out if in their processing, they factored in the various, because in the various softwares, they have models for their ionosphere and troposphere and all those errors. Did they check to ensure that the models were the same before because if one software uses one model and you process them raw like that, because most often the post-processing that is done raw. We just go in and use the default settings. If you don't factor those things in, you get results and you think you are wrong. So I wanted to find out these things from him. Thank you.
Oh.
Or is it another presentation? Yes, I think this question will have to be answered. So as soon as he comes back, we'll give a go at that. But ladies and gentlemen, moderator would tell you how we want to handle 11. And so let's see how it goes.
Okay, thank you. So as I said earlier, we've learned a lot of things for the whole of the semester. Sorry, as if I'm in class for the whole of the seminar, and it has been great. Linking smartness to surveying has been a great thing to discuss, and I feel that at this open forum, being able to answer these few questions we have here, we can actually have a presentable document that will way forward in our dealings. First and foremost, surveyors begin to think and act smart. That's the first question. How can surveyors begin to think and act smart? Why would we want to act smart? What is the essence of acting smart? If you're able to act smart, are we going to get more income? Are we going to make progress with the way we handle our land tenure systems? All of these things are a package. One of the presenters presented something very interesting about how cadastral plans can be produced by the click of a software. And it's also a process of acting smart. The second question is, how can we impact on Ghana's digitalized economy with our smartness? How can we impact on Ghana's digitalized economy with our smartness? The third one, how can we deploy geospatial solutions for our national development? How can we deploy geospatial solutions to our national development? Okay, so we have 10 minutes to answer all these questions. But then there's a last question. And the last question is a comment. If you have any comments on our team we have for this occasion, you can also make that. So let's start with the first one, Chairman. Any contribution, please?
I think that is the easiest way we can collect data now. So if we can trust the accuracy of set maps, I want to say through modern wider technologies for survey. Yeah. Yes. Yes. We shouldn't just
ASAS is more technology, expansion of technology use in our activities. 2, accepting. Okay. Any comments? Director, you are smiling. I know you have something to tell us. Yeah, director is here, so please, just something, for us to take home. We are thinking smart and we want to act smart. And our colleague says we should look at the expansion, the use of more modern technologies. And Mr. Director, one of my finance colleagues told me, he says there are 3 technologies: nanotechnology, computer technology, and geospatial technology. And look at the geospatial space. It means that it is so huge. And so therefore, if we don't run, time is of essence. And if we don't run and take advantage, it is always going to eat us up. So we want to hear from you some wise words about how we should act in order to be able to catch up with time.
Okay. I don't want you to break protocol. Director will speak last. So I'll take it for you. I think from my point of view, the technology and other geospatial products are there. I think it begins from us as individual and as a group. We ourselves should make sure that we are competent in whichever area we are working. We know the basic principles underlying whichever area of our surveying work that we are doing. When we know that, then from there, we should be able to apply the technology we are talking about and think fast. In doing that, you have to be selfless. You don't have to be selfish. You have to think of everything as to what is it benefiting X today and how will we get a benefit in the future. If we want to add something to the value of knowledge we have, then we have to be selfless. You don't have to be selfish. Think of others and the profession and for the future. Thank you.
Hello. Yeah. Thinking Smart. Abdul Hanan Idris Abu, Alaji 4. Alaji to the 4th power. Okay. From SMD. Thinking Smart and Acting Smart. Collaboration. If we cannot collaborate, you can't act smart. One person, what do I say that? One person cannot have it all. One firm cannot have it all. So we need to collaborate and look at our competencies, do the collaboration, and I think we'll go far. We shouldn't be selfish. Like Senior Aditya already said. Once you are selfish, you cannot handle anything. Selfishness takes you back. You can't achieve your optimum. So put selfishness as a firm, as an individual behind you, and then when you collaborate, you achieve more. Then the third is explore technology. You might have certain aspects of technology, others might have others. So put these things together and then you go a long way. Data sharing, data and information sharing. If we have all these together, what you have, another person has some other aspects. If you bring this together, you achieve more. This is thinking smart and acting smart. I think if we are able to do collaboration, data sharing, then what is the other one? But if we have this together, I think it will go a long way to help us as surveyors.
A hand of applause. Okay, so most of the comments that are made by fellow contributors are basically about collaboration. Collaboration is the key thing in handling most of the smartness. If you are smart and you have, if this person has data, you also have data and you bring it together, because this guy has been able to prevent you from wasting so much time in going to produce the other data sets. You are easy to go with the ones you have. So the main message there we have is what? Collaboration. Now, next question. How can we impact on Ghana's digitalized economy?
Yes, last one. To read. Okay, so my name is Bright Kwesi Mensah, SMD. One of the things we can look at in terms of smart thinking is for you to be able to identify problems. Once you're able to identify a problem, then you can actually think behind the box and then find solutions. And then at the end of the day, we'll be able to achieve whatever we want to do.
Okay. Chairman, a lot of hands are up. Yeah.
Yes. Thank you. We must also learn how to lobby government. Why do I say so? anything you want to do and you don't have the support of government, it's not going to work. The politician must buy into whatever innovation you are bringing on table. So that is what I also want to add. We should learn how to lobby. So whereas we are always in our silos, we should come out, talk, and let people understand what we can offer the society. Yeah, thank you.
Good.
We want to host, you will have a session with this committee when we are done. His technical committee is a very important technical committee of parliament, and he's prepared to listen to it. So let's try and put all of these things together and make presentations to them and see the buy-in of the political front. Yeah, so let's go back to what we'll do is that because of time, and we need to consider all of this. When we have looked at the 3 questions, then we can add more. So the second thing is, how can we impact on Ghana's digitalized economy? What role can we play?
Any contribution, please?
Somebody there, this software or this process that he's been able to do. Let's celebrate him. Let's make a lot of noise about it. That is how people appreciate value. If we don't celebrate ourselves, self-defeatist. So I would say championing, any innovation and any good idea that we have will be one such great move about how we impact on the economy. And I believe that in championing, let us see how we roll it out. Let's see how we roll it out, publish it in other publications and all of that. So that's what my view. Any additions to that? Yeah.
Thank you, Mr. Chair. I'm Surveyor Isaac Marcel Azoniade from VRA. I think as professionals, we should, once we are seeing what we are doing as a means to an end, we'll be able to make impact, and it influences whatever we are doing. It is not the end. Thank you.
Thank you. I'm Colbert Kwame Abakulun, SMD. I think we as surveyors, we should also spread out. I mean, by going into the hinterland, see problems, how can we solve those problems? Instead of sometimes being concentrating in one part of the distance without going into the hinterland to see what is happening there. Let's be the first to see the problem and bring it out before people begin to talk. That is what I think we should do.
How can we impact on Ghana's digitalized economy? I think the digitalized economy is supposed to solve particular problems. So first, we need to identify what the problem is and provide solutions from the geospatial point of view. If we cannot do that, we can't go in there. So what do? Is it about flooding? Is it about whatever we think the surveyor or the geospatial informatics can do in solving the professed problems that the Ghana's economy needs to? Then I think we can enter into that without identifying what problems this the digitalized economy is confronted with. I don't think as professionals in that environment, we'll be able to do it. So first, identify what the problem is, and then propose solutions from our point of view. I think if we do this, we'll go a long way.
The digitized economy is based on location. The digitized economy is based on location in terms of positioning. And we are already there. In terms of the services and most of the digitized areas of the government is survey and GIS, Graphic Information System. So we have to take the lead. The computer science and civil engineers are rather coming to our area and trying to project that they are the lead experts. So rather, we should encourage the teaching of surveying in our polytechnics and our universities to have departments. And even most of the government agencies wish to advocate that there should be lead GIS experts from the geomatic area, since we are the lead agencies. Apart from that, like Mensa explained here with his presentation, there are location-based solutions. There are food hidden somewhere. People don't even know that they got mangoes there to be picked and the road access. All these are location-based information to make sure that what we are doing is known. At times, like Kwame said, we have to celebrate our people and make noise. We are already impacting on a digitized economy, but we are not talking, and others are trying to study what we do and take it out from us. We can also do more. Thank you.
Okay, I think we'll check. It should be as brief as possible.
All right, then. What I want to add is looking at rural urban migration. Currently, we are in Tamale now. Last annual seminar, we were in Sunyani. Then obviously Accra, we don't even want to go to Accra anymore. What just dawned on me when I got to the Tamale airport was an aerotropolis set up for Tamale. So as what geospatial solution can we put in place to tell the government of Ghana that you need to up Tamale to become one of the modern cities in Ghana? So for me, the challenge is, in order to curb rural urban migration, we need to ensure that we can get Tamale to become a modern city. And we can use geospatial solutions, the one that Felix Mame's paper can look at all of that. Then we can have a solid paper convincing the whole of the country that we need to put Tamale up as another modern city. Thank you.
So he says advocacy. Talk, ask. Advocacy.
My name is Sylvia Lawrence Adipa from VRE. Yes, I think we can also do this, but in our own small way where we find ourselves, that is in our offices. So I want to give a practical example of what VRE, the survey section we are doing. Now, we have deployed drones and we are using AIs on our pylons, our electric lines, to identify trees that are so close to the pylons. You know, when it rains, some of these trees might fall on the lines and causes blackouts. So now in the Akosombo enclave, this is what we are doing. We are flying drones around to identify trees within a certain corridor. Let's say 5-meter corridor, left, right. We identify all this and then we deploy men to cut them off so that when it rains, this will not happen. Another way we are also doing is in terms of spillage in our dams. When you spill of a certain volume, it gets people displaced. So we have come up with maps, generated maps, that when we spill of a certain volume from about 5,000 to about 12,000 cubic meter spillage, the area it covers. So before we do that spillage, you already know areas that are going to be covered because we have satellite imagery covering all those things. So we go into those neighborhoods and then we pre-inform them. So these are the few things we are also doing in our own way. And I believe in digitalization, as we said. We can start it small in your offices where you are, champion it out and do something to help. Thank you so much.
Okay, so we are moving to the final question. So, okay, so how can we deploy the spatial solutions for our national development? For our national development.
First and foremost, we need to consolidate all our core stations in the country. That is first point of call. And I believe our able director is here, and Lands Commission Act 2008 spells it clearly. So we have to try and move into an implementation stage whereby we can get all our cores under one umbrella in line with NSDI and all that, so that we can now say that we can give our data sets to IGS and say, like, look, all our stations can qualify for IGS standard. Then we can be able to use that for all kinds of cluster movement, whatever applications we want to do. So the first point of call is to get our cores right. Then we can have a file for our cores in the CSV. Anywhere you are in the, as a surveyor, you have the SAR cores. You can access it anywhere on your notebook or on your laptop. That
Thank you very much, Surveyor One.
Thank you. My name is Linda Abusi. In addition to what VRA said, I will also say that point 3, we should also move at the same speed with technology. Technology is moving so fast, and as surveyors, we shouldn't be in our small corners trying to do the traditional things that we used to do. We should move quickly, we should learn so that we can also move with the same pace. It shouldn't take us by surprise. If I have been using theodolite for a long time, now there's RTK, there's drone, I should also know that it is still the same first principle surveys that these machines are using. And I should be able to understand them, use them, and then assess my data and know that it's giving me the same thing. So we should move along with technology. Thank you.
That's great.
Yeah. So we have all been talking about technology. We are gathering data. Where are the data? We have our geospatial policy still on table. So like my brother said, we need more collaboration, and let us push for that policy to become a working document. Say that we can put all our data that we capture into a geospatial data infrastructure, so that we have the data and can share data, analyze, make informed decisions for management and politicians to be able to take good decisions for us. If we are talking about technology and we are all working in our silos, we are all having our data somewhere, and we don't put it together, the country doesn't have anything. If there is a problem and they ask us to come out with data to support, I'm not sure we are going to be able to do that. So please, let us also be thinking about putting our data together. We have a geospatial or a national spatial data infrastructure where we can have all the isolated, what do you call it, geographic information systems sitting elsewhere. We put them together, we can share data, we can link to other systems and get information. mind you, we are all using the state funds to collect the data we are talking about, and we need to also put it in shape such that we can always share. Thank you.
In my opinion, we need to convince the politicians to toe our line. If the politician doesn't buy, if they don't buy into this, I don't think we are going anywhere. So we need to advocate and then to be able to convince them with practical solutions that they can easily understand. Then I think with that, they will buy into it, and then we'll have a way to move. Thank you.
Chairman, let me also say one more thing before you go to the last one. Yes. I see the three questions as very relevant, and it looks like they fit into each other. Whatever answer we'll get for question 3 also answers question 1 and 2. And it's very critical that we are coming out with answers for all the 3 questions. Now, the spatial solutions, we have spoken about spatial data infrastructure. Of course, sharing data is very, very important. As my other speaker said, data is sitting in silos. And if you even look at how the data were collected, in or push for that so that data can be shared by everybody. Of course, developing a national data infrastructure also means that we come out with spatial solutions, tools that can be used to manipulate and share data is very, very important. So we as surveyors must be able to come out with tools, just spatial tools, developing tools, for the sharing of the data. So Chairman, that's all that I can say.
Thank you very much. And it presupposes that it leads us into what they call data governance, the integrity of the data, and then how data is archived and shared. So we'll look at data governance as one of the actions that we're going to do. I'll take the last person there, and then we'll give an opportunity to DOS to talk to us.
Thank you, Chair. I think we are talking about geodata solution. And we are geomatic engineers sitting here. Geodata is all about location. And we as geomatic engineers, all we do is collecting data. In the police sector, they have come out with this jingle. If you see something, say something. We have so much seated in our records. We've not been able to push them into the political front for people to know what we have when they come to geospatial. I think the solution lies largely in our palm as geomatic engineers. what we are failing to do is how we package the data we have, we refine them so that they will meet demand. And also the policy. We should study the policy and know where we fit in terms of providing solution. Thank you.
Yeah, so Lana, your audience.
Thank you very much. And thank you for this opportunity. What I have to say is not going to bother on the very nitty-gritty of the technical aspect of issues, but the administrative aspect. I think for anything that you want to embark on, you must be looking at who is the champion. Which champion is going to lead us? If you don't identify that kind of person, and it is what I have noticed few months, a year or so on the seat, is that surveyors, we have that attitude of obia and obia, if I have to, well, if my tree is right. You know, well, the deputies, they talk about geospatial policy. And indeed, I had to do a write-up, and that meant that I now had to go through the geospatial policy and get to understand certain things. And when you go through the geospatial policy, you see that a whole lot of enormous responsibility is put on the director of survey to be a champion, to be the lobbies, to be whatever. But you come down even to our current situations. Let me go to the restructuring of Lands Commission. A director is supposed to be a common director today. He's supposed to be at par with the regional lands officers. Today, a director cannot easily say, I want to see the minister. I want to see so and so. Our system is such that the director's authority and wings are being clipped by the day. Meanwhile, your geospatial policy is even talking of him as the champion. How do you clip the champions while the wings and expect him to beat? Boundary commission. A military man is there. He thinks he must champion. Unfortunately, some of us here, licensed surveyors, we go and we make ourselves, subordinate officers. And we want to even bring the director of survey under the military officer. I remember I did a movement of somebody in Tema who for 4 years had about 20 days registered in his name at the office. And who was countering it? When background investigations, another military man sitting somewhere who thinks this person must stay in Accra and work for him. Come back to conferences that the director of survey would normally have attended. We know too well that surveying is a very broad area. Talk of geodesy, talk of photogrammetry, talk of GIS, and all the gamut. Today, even photogrammetry, you are talking of remote sensing and all those things. Champions should even have other little champions. But then when the main champion is not even was recognized, in which direction can we be going? So to be talking of smart thinking, AI, and all that, if you don't identify the champion, if you won't give reverence to the person who should take the lead, then we better just make this thing the talk shop that we always have. And then we walk away and go and sleep. I, like I said, don't want to go down to the technical bits. I was involved in the GEM project, and somewhere along the line, I dedicated myself to programming. And I do know what it takes to write a script. My former director was here. And I think those days he will run away from those aspects, because that's a very tedious thing to do. And so you even require to go deep down there to see that, oh, this young man sitting there, what he's doing is very relevant aspects of the AI and the smart thinking. Certain times you take a certain activity, and when you go home, you are not going to have a sound sleep. Your mind is still on that activity, so that's what you can get it finished. So let me not, it's not to lecture much, but I want to just say, let's identify the champions. Let me, maybe I would want to give this 2 issues again. I remember last year I was at Afrigis. Afrigis, after being, gratefully, chosen as chairman to represent West Africa, we kind of ended, we were not able to end with what our deliberations. And the issue was, let's all go to Ethiopia. And then at that UNGGMI meeting on the sidelines, we can finish up. And I'm sitting there, well, I don't know of any UGGMI. Then they go, but your country, oh, there's some John B who is represented. And I knew the person. So the discussion was, no, this is wrong. These positions are for the director of survey of every country. We have the major one in the US, and then we come down to the continental ones. Lo and behold, I had to pack my bag and come home. I came, mentioned this, and I was like, even it's not just about the director of survey. The kind of structure the director of survey has around him is a very solid team. And we will remember the first one my uncle was here. Those days of his travel as the key technical person, he had one of our technical senior officers who was always around him, so that he will, when they go around and come, he will be the one who will follow up and see to the implementation. Today, even as the director of survey, it is seen as a favor to be done you. This year, just this year, one of you called me from South Africa. Oh, why are you not in South Africa? They say Ghana was missing out. I sent him the email correspondence I had with somebody. I don't want to mention. So if we can't identify or give the support that is needed to say the champion that we should all be recognizing, I think we may just be making noise here. So for me, the plea is to try and restore the dignity, the authority of the director of assembly. It's a collective responsibility if we want to really be seeing ourselves as driving change in this country. Let me put it here. Thank you.
Thank you very much, Director. Let me
Yeah. So let's give reference to authority.
So quickly, let me just do this. I want to give a rundown of events. You can keep clapping for the director. We are in the region of clapping. So clap. Yeah, so Mr. Director and distinguished deputy directors and my colleagues here, I have had the cooperation of all of you in chairing this session. We started off by looking at some topics, some great topics, which we treated. And then the first paper was quite technical, and it was about identify the problem, we cannot prefer solutions. And how can we get it right? We can get it right through celebrating our champions. We can get it right through identification of the problems, and then knowing that mostly we are doing location-based, and more importantly, we are also doing advocacy. And then the DOS, very emotional and very touchy. Everybody knows. I have been to the Supreme Court because of the issue he's talking about. At the time, we didn't have that much support. But there's still an open door, because in the judgment itself, the judges left us an open door. But I'm tired, so anybody with anybody with their wings and clouds who can continue the fight, you're welcome. Because it doesn't make sense. It does not make sense. In fact, if you look at it policy-wise, it does not make sense. If you look at it common sense-wise, it does not make sense. If you look at it governance structure, it doesn't make sense. So in all of these spheres, the judges admit that it doesn't make sense, yet they say they will do it differently. So they have asked us to come and explain to them why they should accept doing it differently. But as I said, some of us are tired. Some of you have the energy. You can take the mantle on. And Mr. Director, it's very unfortunate. It makes me very emotional that we can see our own survey department and survey division. You know, we even had Justice V. CRC Crab draft the Survey Authority Act, which I had in my possession, which I was advocating for, which copies were sent to Parliament, so that we can then move the whole survey organization away from any of those, institutions and have them become an independent authority, so that they can champion the leadership that you are talking about, so that they can come out with policy decisions, coherent policy that, would help the nation. And as Professor Lumumba, I'm sure many of you have been PLO Lumumba. He says Africans, we like, we don't do what is called teamwork. That is what is killing us. Teamwork is absent. So if you go to international engagements, races, and all of that, you see Africans are doing well in the individual, 100, then one man, 200, one. Because the last line, somebody is holding your belt and pulling you back, and then he claps and laughs and celebrates actually pulling you back. That's how we have become. So until we change our own character and stuff like that, we're going to be where we are. I understand where he's coming from, but he must make the noise. So I am imagining a day without this surveyor. This is another, positive action that we can do, not because of the strike nature of it, but just to demonstrate what our absence denotes. A day or a week without the surveyor. We sit in the office, no licensed surveyor, no professional surveyor, no government surveyor, official surveyor, no work. A day without the surveyor. And then when we finish, things will come out. Aduti wants to tell you something, and I am obliged to allow him, even though I wasn't going to allow anybody to speak again after the director of survey
VS conference. We have Esri, we have Geospatial, we have UGTF. You will be the director of survey. Now people want to travel. You will see that there's a list, not only 1, 5 people. Deputy minister, and your office. Our colleagues, you probably have to say it. You mentioned Victoria said it. Valua, this, all in the plane. They come back a minute to you. They go there, they sleep. Because it's technical, they don't understand it. And then they expect you to implement it. So imagine that they rotate the presidency of RETAS, Regional Center, where we train our, most of you went there. And he is now the chairman for all the regions, Senegal, Nigeria, and they are telling him we will meet in Ethiopia, and he's not aware. So in your own home, you are not recognized as a surveyor general of your state. So we should not look at the person, but at the office. So what we are saying is that all that we are saying, who is going to champion it for you? If you don't do it, highways, the minister will let the civil engineers set up GIS offices in even your own survey department. So somebody said we should lobby. It's good, but you lobby through the director of survey, or the law is on his side. So if we go back and we start dividing ourselves, survey for power and others, you are part of them. I had to go to Kapoha and defend surveyors. When I was a director, I had to go to highways. If you touch a surveyor, because I'm director of survey, I'm not director of SMT. They told me to not use the director of survey. That's how we use it. But the legal department came and said by the laws and functions given, it's a change. I can call myself director of survey. So when you are there, they are deciding for all of us. So for me, short term, we have to, not to use that. The deputies, let us know the conferences, look at the old files that director of surveys was attending on our behalf. Let us look at all of them. Let us look if the name has been changed. If the Lands Commission decide not to fund you, put them in your budget. If they decide, we as a division, and probably other bodies like LISA, will fund the director of survey to attend. If that the short term, and what Kwame said, if you don't do positive action, nobody will hear of you. Pharmacists were being called by the doctors, dispensers, go to my dispensary for medicine. When they spoke out, now they are almost equal. Where we are now, we know what has happened. People are afraid to talk. Why should I be working for 9 years and I'm not fit to be confirmed? And then they tell me you are the most hardworking person. You clear your table because it's a surveyor. But the person has started on project management, basic law, everything. So I ask myself, I'm not against anybody, whether it's a fellow, but the office is a secretary for some profession alone. No. Then let us come out and form our authority. If you think we are not qualified, even to act. So we see ourselves as adjoint or addendum to some other profession. But when it's happening to somebody, we all keep quiet. The director of survey has been confirmed. His position to, if we don't take time, next time they will bring a value to the director of survey. Thank you.
All right. Thank you very much.
You see, we're entering into an emotional realm. And for me, my recommendation is that many will talk, few will act. I have been in the war front, and my brother, my small brother, Hanan, his father tells me that I am a fighter and a combatant. So let's create more. Yeah. It's lunchtime. Even though we are clapping, I can see that many of us are looking gloomy. Some didn't have breakfast. So on behalf of DOS, Director of Survey, I'm sure we'll pick up our gloves and begin to fight again.
A few
even though I'm tired. Let's listen to that.
Yeah, a few announcements. After here, we are all going to the booths to see what our sponsors have for us. And then afterwards, we'll take the photograph before. Okay, we are going to take the photograph before, then we'll see what our sponsors have for us. Then we can go to lunch. The dignitaries are supposed to have lunch in the holding room, and they will return back at 1:30 p.m. Thank you.
It's 1:30 for the AGM. Is it?
Yes, please.
Yeah,
1:30 for the
1:30
AGM.
Thank you very much. Meeting closed.
Chairman.
Yeah, so some statistics. When we started, we were 44. We ended up with 96 participants. Clap for yourselves.
So before the AGM, we'll have a YSN program before the AGM starts. So if you can excuse you. Please, we are going downstairs for the photograph. Downstairs. Yeah.